In this module, we're going to answer the question, why do we need railway signalling? And I'm going to give you 4 different reasons. The first is to control the safe separation of trains at speed. The second is to move, lock and control speed over points at junctions. Third is to prevent conflicting movements over junctions and bidirectional sections of track. And the final is to ensure the safe operation of level crossings. In road transport, there is a good and reliable grip of rubber tyres on tarmac that enables vehicles to brake from relatively high speeds in a short distance. So, taking the coefficient of friction of 2/3 that is used in the UK Highway Code, this gives a braking distance of only 75 metres from a speed of 70 miles an hour. And adding to that a thinking distance of 21 metres, that gives a total distance to stop of less than 100 metres, a distance that we can reasonably expect a driver to look ahead and judge distance and what's ahead and be able to stop safely in the distance that can be seen to clear in driving in what we call an on-site mode. By contrast, in railways, we have steel wheels on steel rails, which, in ideal conditions, can indeed achieve a good grip. That grip is much more variable than is the case for rubber wheels on tarmac, and typically significantly less. So for a safety critical function like braking, we can typically only rely on a coefficient friction of around about 1/8. And furthermore, the brakes don't apply quite as quickly as they do in road vehicles. They typically take a while to build up pressure, particularly on long locomotive hauled trains. So, applying this same driving on-site principle that we use for road vehicles to railways would require trains to travel at very low speed. So, whereas we can comfortably operate at 70 miles an hour with a drive on-site principle based on drivers being able to judge 100 metres or so ahead, being clear of obstruction. Even with a passenger train with good brakes, that would limit speed to probably no more than 25 miles an hour. And by the time we get to heavy freight trains hauled by locomotives, the distance, the speed would typically be limited to give or take 10 miles an hour, neither of which is particularly useful for running attractive railway services. Signalling overcomes this limitation by proving that track is clear of obstruction for hundreds or even thousands of metres ahead of the train and indicating this to the driver so that drivers can drive their trains at high speed, confident that they have enough distance to stop if they need to. And this not only enables trains to travel as fast as road vehicles, but in fact much faster. Whereas road vehicles remain limited to around 70 miles an hour by the driver on site principle, mainline trains frequently operate at 100 miles or more, and there's even many new build high-speed lines where trains can operate around 200 miles an hour, all thanks to railway signalling. A further difference between roads and railways is how junctions operate. In roads, junctions are simply tarmacked over and drivers turn a steering wheel to take their vehicles on different paths over the junctions. By contrast, trains on railways always follow the rails that are laid down for them. Hence, to take a different path over a junction, the rail themselves must be moved using points, also known as switches. And it is one of the roles of signalling to move these points via various types of actuator and to lock them in position so that any trains travelling over them in the facing direction are not going to be derailed by the points moving underneath them. Further role of signalling that's perhaps less obvious is controlling the speed that trains traverse junctions, because typically junctions have a straight through route that can be traversed at the full speed for the line, and a diverging path on a curve that must be traversed at a reduced speed owing to the centripetal acceleration associated with the curve, which increases in proportion to the square of speed. Hence, to keep centripetal acceleration within acceptable bounds, we need to reduce the speed. For the sake of passenger comfort and safety, bear in mind that passengers may be walking around the train or carrying hot liquids. We need to make sure ultimately the train doesn't travel over when travelling around the curve and avoid damage to the points themselves that could result from the force associated with the centripetal acceleration. Like signalling can inform train drivers about point positions in one of 2 ways. One approach is known as route signalling, whereby the signalling indicates the path to be taken over the points and relies on driver route knowledge to control speed appropriately. that are known as speed signalling, indicates the maximum permitted speed over the points according to the path over them. Traditionally, mainline signalling in Great Britain has adopted a route signalling philosophy, whereas European Train Control System, ETCS, is now becoming more prevalent, adopts a speed signalling philosophy, as is more common on continental railways. Railway signalling, like road traffic signals, also plays a role in preventing conflicting movements over junctions. Where we have different traffic flows over a junction, we need to make sure that they both don't flow at the same time. And similarly, where we have the potential for trains to go in opposite directions over the same piece of track, we need to make sure that they're not authorised to do so at the same time. And likewise, where a railway crosses a road, we need to make sure that the road is closed when the trains are authorised to travel over it, and likewise that the railway is closed to traffic when the crossing is open to road traffic. So, in summary, why do we need railway signalling? We need railway signalling to enable trains to travel safely at high speed by proving track is clear for hundreds or even 1,000 metres ahead of the train and indicating this to drivers. We need signalling to move, lock points and provide information to drivers to control speed appropriately over them. We need signalling to prevent conflicting movements over junctions and bidirectional sections of track. And finally, we need signalling to ensure that level crossings are not simultaneously open to rail and to road traffic. Thank you for your attention. In our next module, we're going to have a bit of a history lesson looking at railway signalling from the steam age to the information age.